Hello everyone, welcome back to my YouTube channel. Today we are seeing class 10, science 1, chapter number 3, chemical reactions and equations. In this particular session, we are going to discuss about the balancing a chemical equation and the different types of chemical reactions. In a previous session, already we have studied about the chemical reactions, what exactly they are and how to write them. Now the next part is when we talk about the chemical reactions. On the left hand side we are writing the reactants and the right hand side we are writing the product. So number of atoms of each and every element on the left hand side should be equal to the right hand sides, because number of atoms cannot change, they are going to be there. Only what is changing is a chemical bond between the different atoms. So number of atoms should be equal for each and every element. Like in a previous session, what the equation we had seen, that is AgNO3, silver nitrate, is reacting with the sodium chloride and forming the AgCl, that is a silver chloride with a sodium nitrate, that is NaNO3. And for this, we have to write the number of atoms present over here, so that this particular section you can do by yourself. I'm not going much detail in that, only the reaction we have to see and the number of atoms we have to write down. I'm going directly towards the steps involved in balancing a chemical reactions. So first of all, step number 1, what we have to follow is write a chemical equation from the given word equation. Means whatever equation is given to you, first you write down. If it is given already in a molecular formula form, then that's okay. If it is given in a word form, like here they have given us a sodium hydroxide plus sulfuric acid gives us a sodium sulfate plus water. So these kind of word equations, first we have to write down in a molecular form or the chemical equation form. So that is already mentioned over here, that NaOH plus H2SO4, Na2SO4 plus H2O, means sodium hydroxide reacting with the sulfuric acid forming a sodium sulfate and water. After that, the next step what we have is to check whether the equation is balanced or not by comparing the number of atoms of the various elements present on the two sides of the equations. Now here if I am seeing about the sodium, this side we have only one sodium and here two sodium, so that we will write 1 and 2. For oxygen we have 1 here and 4 here, 5. Here we have 4 plus 1, 5, that is balanced. Hydrogen here 1, here 2, so that is 1 plus 2 is 3, and this side we have only 2. For the sulfur if I am looking, then 1 sulfur is here and the 1 sulfur is here. So in this if I am looking, only oxygen and sulfur is balanced because both are 5 here and both are 1 here. The hydrogen and sodium is not balanced. So we have to balance them. We have to make such a difference in the number of molecules so as they will be equal. Now the next step, what is required, it is convenient to start balancing an equation from the compound which contains the maximum number of atoms. Moreover, it is convenient to first consider that element in this compound which has unequal number of atoms on the two sides. So what we have to look, that which particular element is unbalanced, and then afterward which one is having a more number of atoms, that we have to select. So here number of sodium atoms. First of all, we will look about the number of sodium atoms. Initially it is 1, and in the product in Na2SO4 it is 2. So what I have to do, I have to multiply it by 2 for balancing. Then afterward, once I am balancing it, so what is changing along with that? Oxygen is changing, hydrogen is changing, and the sulfur is also changing. So similarly on the right hand side also, what we have to do, we have to make a changes according to this. Further, number of atoms of hydrogen initially 4 and here 2 we are having, so this I have to multiply by 2. Write down the final balanced equation then. So final balancing, that is 2 sodium hydroxide will react with 1 sulfuric acid H2SO4, and it's forming a sodium sulfate, the one molecule of that and the two molecule of water, and then it will get balanced automatically. Next is the types of chemical reactions. We are having different types of chemical reactions according to the nature of their reactant and product. On the basis of that, first we have combination reaction. Combination reactions are nothing but the reactions in which the more than one reactant is combining and forming one single product. Simple words. By the word itself, combination reaction. Combination means combining. If there is a two or more than two reactants are chemically combining and forming a single product, then that kind of reactions are called as the combination reaction. You can see over here the examples are like ammonia and hydrogen chloride. It's combining, these two are combining and forming a single compound, that is ammonium chloride. Another example they have given over here is of magnesium and oxygen. If I'm burning a magnesium, it's combining with the oxygen and forming a magnesium oxide. Same way, the next one is a calcium oxide reacting with the water and forming a calcium hydroxide, and the heat, that is the energy, is generated. So these are the examples of the combination reaction. You can see the definition they have given. When two or more reactants combine in a reaction to form a single product, it is called a combination reaction. The next one is a decomposition reaction. The next reaction is a decomposition reaction. By the name itself, decomposing. If a single reactant is forming a multiple products, in simple words, if a single reactant is forming a multiple product, that kind of a reactions are called as the decomposition reaction. Example they have taken here, the sugar is breaking down into a carbon and water. So this particular reaction is nothing but what? Example of a decomposition, because a single reactant is forming a two products, and that's why this particular reaction is an example of a decomposition reaction. Further is another example they have taken over here is of a calcium carbonate. When we heat calcium carbonate, it separates out in a quicklime and releases a carbon dioxide gas. So this is nothing but the example of the decomposition. Another example, water liquid. If we will heat it, it will produce a hydrogen and oxygen, which is also called as the electrolysis. You can see the definition they have given over here. The chemical reaction in which two or more products are formed from a single reactant is called decomposition reaction. Further is displacement reaction. Displacement reaction means when two reactants are reacting with each other or goes under the process of a reaction, in that one of the ion replaces the another. One of the ion replaces the another is called as the displacement reaction. Let's see the definition what they have given over here for the displacement. The reaction in which the place of the ion of a less reactive element in a compound is taken by another more reactive element by formation of its own ion is called displacement reaction. Means one of the ion which is less reactive will be replaced by the another element by forming its own ion. This particular reactions are called as the displacement reaction. Like here you can see they have taken the example of the copper sulfate reacting with the iron. Iron is more reactive than the copper, so it will form FeSO4 plus copper will be released out. Same way here it will form a lead sulfate PbSO4, and here again the copper will be released out. Further is double displacement reaction. The reaction in which the ions in the reactants are exchanged to form a precipitate are called double displacement reaction. In simple words, here two displacements are taking place simultaneously. In a simple words, to understand a double displacement reaction, the proper scientific definition they have given over here: the reaction in which the ions in the reactants are exchanged to form a precipitate are called double displacement reaction. Example they have taken over here is a potassium chromate into the solution of a barium sulfate. So this reaction you can write by self. Another they have given over here is the endothermic and exothermic process and reaction. When we talk about this particular type of reactions, that is the endothermic and exothermic reactions, this is particularly based on the heat or the energy what they are liberating or what they require to carry out the reaction. There are the certain reactions which generate heat during the reaction, and there are the certain reactions which require heat for the reaction to occur. So on the basis of that, we have two different category of the reactions which we call as endothermic reaction and exothermic reaction. In reactions where heat is released, that kind of reactions are called as the exothermic reactions, and where heat is required to carry out the reactions are called as the endothermic reactions. Further, to carry out the endothermic and exothermic processes, they have given the one procedure over here, the practical part, the endothermic and exothermic reactions. The examples they have taken over here: calcium carbonate. When we heat it, it produces a quicklime and carbon dioxide gas. And when that quicklime, we are adding a water to it, it's forming a calcium hydroxide, and the heat is generated, so exothermic. In the first case, we require heat, so endothermic. In the second case, heat is in a product, so it is a exothermic reaction. So this is about the types of chemical reactions. In the next session, we will talk about the rate of chemical reactions and the factors affecting them.